What are insulators? What are insulators? Have you heard or not heard? So, what are insulators? Speak louder. Bad conductors of electricity are the materials which does not allow current to pass through it. Such materials are called as insulators. Why the materials are not allowing current? What is the reason? Why a material is not allowing current to pass through it? Lack of free electrons. Lack of free electrons. Electrons will be there in bounded form. Free electrons are responsible for conduction. If free electrons are not present, such bodies are called insulators. So, all dielectric materials are insulators. All dielectric materials are insulators, but all insulators are not dielectric materials. All insulators are not dielectric, but all dielectric materials are insulators. Right. All dielectric materials are insulators, means they do not have free electrons for conduction. These are used to increase the capacity, means used to store the energy. Okay. But if you take a insulating material, actually it is a substance. Substance is made up of what? Substance is made up of, every substance is made up of, every substance is made up of atoms. Every substance is made up of atoms. Atom is made up of, atom is made up of, louder. Atom is made up of electrons, protons and neutrons. How about their arrangement? Neutrons and protons are present inside the nucleus, electrons are orbiting around the nucleus. And atom is electrically neutral or not neutral? Atom is electrically, means equal number of electrons and protons are present. Okay. What about the center of this protons and electrons? Coincided, not coincided? Generally atom, positive charge nucleus, negative charge electrons are orbiting around the nucleus. What about the center of these two? It will be coincide, does not coincide generally. It is a circle. Circle center will be where the nucleus is there or not. Okay. So, center of positive plus related to nucleus, minus related to electrons. Now, when this is a atom in a substance, when there is no external field is applied on the substance, on the material, that is arrangement of electrons and protons that we are going to see. Electrons and protons center is coincided. Now, what I do? I will apply some external electric field, some value will be applied on this. So, what we are going to see? The positive charge will move in the direction of, the positive charge will move in the direction of applied electric field. Means the centers will be coincident, no? Both are same. Here plus and minus, protons and electrons center is coincident, whereas here any possibility is there. So, centers are not going to be coincided, means electrons and protons are separated. Electrons and protons are separated. This is called as formation of one positive charge, one negative charge. These are nothing but called as charges, poles, electric charges or electric poles. Actually, pole is a word related to magnetism. In magnetism, north and south pole word will come. Here, poles, electric poles, positive charge one side, negative charge, nothing but polarization we say it is. What we say? polarization. Where this polarization we are going to see? Inside the substance. When the polarization we are going to see? When external field is going to apply. Means when external field is applied, what we are going to see? The electrons and protons are going to be separated. How much separation? Some separation is there or not? Gap. How much separation? Depends upon the field strength E. Depends upon the field strength. Separation of charges we are going to see. Like how many charges are separated? Formed? 2 charges called as dipoles. What you say? Electric dipoles. What you say? Electric dipole. Okay. Where this electric dipoles we are going to see? In the dielectric materials. When we are going to see? When external field we are going to apply. If external field is not applied, what we are going to see? The centers of electrons and protons are going to be coincided, no dipoles. Okay, na? So, di means 2, poles means polarities, charges. What are the polarities? One is positive charge, the other one is negative charge. Okay, dipoles. Now, what about the strength of positive and negative charge of an atom? Will be same. The strength will be same. That strength charge. The positive charge is or negative charge is Q. Now, these charges are separated with a distance d when external field is applied. So, that charge multiply with d, we get a new term called as mu, dipole moment. What we say? Dipole moment. What is dipole moment? The product, dipole moment is a product of charge multiplied with the separation between the charges. We get a dipole moment, indicated with the letter mu. What it is? Dipole moment. So, what is dipole moment? Product of charge and separation between the charges or distance between the charges. What about the unit of dipole moment? What is unit of charge? What is the unit of charge? Coulomb. Unit of charge is Coulomb. So, unit of charge is Coulomb and unit of distance is distance meter. So, what is the unit of mu? Coulomb meter, SI unit, Coulomb meter. So, dipoles, dipole moment. Okay. Next, actually we take dielectric material, we pass electric field, formation of poles we call as polarization, that definition also we are going to give. Poles are going to be separated, dipole moment is going to form, but where this material is kept? Material is kept, surrounding this material something will be present or not? What will be present? For example, this desk is a material, let us assume it, or this is a dielectric material. Now, what I am doing? I am applying external field on this, inside separation, okay, no problem. But where this material is kept, surroundings, what is there? Surrounding of this material, what is there? Here, what is there surroundings? If you assume this is a pen, what is present surroundings of this? Atmosphere is present or not? Okay. So, atmosphere is a combination of air. Air is a combination of different gases. Okay. So, we can keep this in air or experiment may be conducted by keeping this in a particular gas, etc. Possibilities there are not. So, surrounding medium information we are going to say in terms of permittivity. It is expressed in terms of epsilon, not E, it is epsilon, permittivity of medium, permittivity of medium. What is this permittivity of a medium? What information we get? Here I want to pass, I want to apply electric field on the material. Okay. So, the medium surroundings will decide how much amount of electric field is passing through it. Possibility is there or not? Electric field plus and minus charge I am going to keep. Between them I am going to keep the material. So, between this medium is there or not? That medium information related to permittivity. If nothing is present, it is called vacuum, called as permittivity of free space, whose calculated value is 8.85 into 10 power minus 12 farad per meter. Permittivity of free space or air. What is permittivity? The medium property to allow the electric line of forces to pass through it. Yes? Yes? Any problem? For free space or air, it is epsilon naught, which is given by 8.85 into 10 power minus 12 farad per meter. What is permittivity? The medium property to allow the electric line of forces to pass through it. Means in a particular medium, it is nothing but indicated with letter epsilon. Permittivity of particular medium is epsilon. This is for free space or air. Means if you compare this epsilon naught and epsilon, it will not be same. Permittivity value is also going to change. Okay. And expression for E is given by d by E. Expression for epsilon is given by d by E, where D is called electric induction. D stands for electric induction and E stands for electric field strength. Electric induction, electric field strength. I am using the word induction. What is induction? Induced. Induction means induced. Induced means something is going to be induced. Actually, later on, displacement vector, there also this capital D word will come. Induction means induction stove, you know. Induction stove. Why name is given? Because how it is going to work. Flux. How induction stove is going to work? By passing of current. Inka? The bowl that is used for cooking, normal bowl or special bowl is used in induction stove? Normal bowl we can't use it. Okay. Where it allows current, such type of bowls must be used. Okay. Next step. So, epsilon means permittivity of free space, epsilon naught. Epsilon means permittivity of a medium. I can find the ratio. Epsilon by epsilon. The ratio between permittivity of a medium to permittivity of free space is epsilon by epsilon naught. This is called as epsilon r, relative permittivity. What we say? Relative. Actually, these are the terms related to dielectric materials. Polarization, dipoles, permittivity, all these things, basics that are used to understand about these dielectric materials. Okay, na? So, particular medium epsilon, for free space epsilon naught, and the ratio between permittivity of a medium to permittivity of free space, that ratio is called as epsilon r. That epsilon r is called as relative permittivity. What we say? Relative permittivity, or it is also called as dielectric constant. Relative permittivity or dielectric constant. Relative permittivity or dielectric constant. So, from this what I can say now? From this epsilon is equal to what I can write now? Epsilon r into epsilon naught. If epsilon r is equal to 1, then what is epsilon? So, the medium will become what? Free space or air. Okay. So, this one you keep in mind, equation, or this also you can relative permittivity, or it is also called as dielectric constants. So, what are the units of this relative permittivity? Permittivity farad per meter for free space or air. What about the unit of epsilon r? What is the unit of epsilon r, relative permittivity? What unit of epsilon? Epsilon naught. So, any units are there? So, what we can say? No units. So, any unit is there? No unit. Okay. It also measures electric polarization in the dielectric material. Okay, this is also used to measure the electric polarization. It is also used to measure the electric polarization in the dielectric material. What are dielectric materials? Where the materials which show polarization. What is the meaning of polarization? Formation of dipoles. When the dipoles are going to form? When external field is applied. Means in all substance polarization is possible? No. Okay, where dipoles are created, dipole moment is there. When these dipoles and dipole moment we are going to see? In the presence of external field. Okay, right. Next, yes. So, any unit is there for relative permittivity? No units. Higher epsilon r easily polarized. If epsilon r is high, that is easily polarized. The material whose relative permittivity is high, such materials can be polarized easily, and good electric insulators, and good electric, yes, good electric insulators means what? Easily polarized means formation of poles when in the presence of external field, as well as good electric insulators means which does not allow, which electric insulator means electricity. Good electric insulators means that body will allow current or does not allow? Does not allow. So, which bodies whose dielectric constant is high? Whose dielectric constant is high, they are very good insulators in terms of electricity, and they can be polarized easily. Okay, na? Right. Next, electric polarization. Next one we are going to see electric polarization. Means what? In that word itself, its meaning is there. Polarization means what? Formation of poles, means separation of charges by passing of current. Yes or no? When you pass current through a substance, or when a substance is kept in electric field, inside the substance, formation of poles, nothing but electric polarization we can say. Okay. Process of producing dipoles by the presence of electric field we call as electric polarization. From this we are going to say about polarizability. Polarizability indicated with letter alpha. Polarizability is indicated with letter alpha. Okay. Before that, already you know, previously I wrote what is mu? What is mu? Dipole moment. Dipole moment is directly proportional to electric field. Dipole moment is directly proportional to electric field. From this, in the place of proportion, I am writing is equal to some constant into E. I can write in the place of proportion. If I write is equal to, here some constant will come or not. That constant, proportionality constant, indicated with letter, this is what? That proportionality constant we call as polarizability. That proportionality constant, what we say? Polarizability, indicated with letter alpha. Alpha is what? Proportionality constant, or it is also called as polarizability. So, from this what is alpha? What is alpha? Mu by E. So, what is mu? Dipole moment. What is E? So, what I can say about polarizability? If E is equal to 1, if E is equal to 1, then alpha is what? Mu. If E is equal to 1, then alpha is equal to mu. What is alpha? Polarizability. What is mu? Dipole moment. When I get alpha is equal to mu, then I substitute E is equal to 1. What is the meaning of that E is equal to 1? Unit electric field strength. When you apply electric field strength of how much? 1 unit, inside the body, dipole moment will be created or not? Whatever the dipole moment which is created, that is called as polarizability. What do you say? Okay. So, for unit electric field, the dipole moment that is created is nothing but called as polarizability. In your syllabus, there are three types of polarizabilities are there: electronic, ionic orientation, and by combining space charge. That also we are going to see later on. So, now I think now you got an idea what is the meaning of polarizability. What is polarizability? Ratio between dipole moment and electric field. So, if I take unit electric field, if I take or if applied field is unit 1, whatever the dipole moment that is created, that is nothing but called as its polarizability. We can say it or not. Next, after this, we are going to say about polarization density. Polarization density or polarization vector P. Capital P. Polarization density or polarization vector P. What is polarization? We take a substance, okay, unit volume of the substance, just you write a induced dipole moment developed per unit volume. Induced dipole moment developed per unit volume in a dielectric slab is called as polarization vector. We know polarization, where we see polarization in the dielectric materials. How much amount of dielectric material you have to take? 1 unit volume. In the unit volume, some amount of polarization, we can see it or not. The polarization that is developed because of applied electric field, that polarization we can call as induced one. Induced is nothing but a forcibly. Induced ante earlier I said induced word. Say you are doing some work, no one is there. Outsider will come and instruct you to do some other work. So, you are forced to do because of his instruction, that is induced work. If no force, freely you can hit it. Okay. Induction induced. So, in the unit volume, what are the polarization that will be expressed in terms of polarization vector P or polarization density, induced dipole moment for unit volume, in the unit volume, because substance has got some volume, yes or no? Unit volume ante enti? Unit volume, volume you know, what is volume? For example, this is a cube or cuboid. This is a cuboid. External field is applied. Polarization we are going to see. Okay, no problem. What I do? This value I will take as unit volume. How much it is? Unit volume. Inside this unit volume, some amount of E we can see it. Sorry, inside this unit volume, we can see what? Mu. That mu in the substance, mu in the unit volume will be same. Okay. How much in we are going to see in the unit volume, that is nothing but called as polarization vector P or polarization density. The expression for P is given as P is equal to N alpha E. What is N? N stands for number of molecules. N stands for number of molecules. Alpha, what is alpha? polarizability. What is E? Applied electric field. Okay, right. In air or free space, this P is equal to what I can write now? N alpha epsilon naught into E bar. What is epsilon naught? Permittivity of free space. Okay. Next, another factor that we are going to see is symbol. How to pronounce it? How you are going to pronounce it? Kai, chi, sai, ఏమనాలి? ఓకే, మీరు ఏమనుకుంటారు అనుకోండి. కయా, చియా, సయ్య. ఓకే, దిస్ ఇస్ కాల్డ్ ఎలక్ట్రిక్ susceptibility. What is kai or sai or chi? It is what? Electric susceptibility. Another term that we have to know in this dielectric materials is electric susceptibility is chi. What is electric susceptibility? See, we have to polarize. What we have to do? We have to polarize it. How to polarize? By keeping in the, by passing through external field. Same materials are there, different materials are there, we got many materials are there. The properties of all the materials are same or different? Appears to be same physically, but inside if you go microscopically, variation will be there or not. Some materials we can polarize it easily, in some materials the polarization is not easy. Possibility is there or not? చెప్పేది అర్థమైందా? This is a classroom. One topic is discussed. One question is kept in front of you. Same type of response we get from all the students. Why? Different students, grasping power is different. Not only grasping, while listening is also might be different. Accordingly, his answer will be there or not. In the same way, we have to polarize it. It may be easy process or it may be difficulty process. That information we get from chi or chi. How easily we can polarize? How easily we can polarize? That information we get from electric susceptibility. What we say? Electric susceptibility in the presence of external. Okay. So, we have to polarize it. We have to polarize it. Means what I can write? P by E. The ratio between P by E gives you chi. What is the meaning of chi? Electric susceptibility. Before chi, we discussed about epsilon. Before this topic, what we discussed? Epsilon. Now we discussed chi. So, what information you get from these two terms? Before this chi, what is this? It is called electric susceptibility. What is electric susceptibility? How easily a material is going to be polarized. Means if you want to polarize a material, what we have to do? We have to apply electric field. So, the ratio between polarization to electric field vector is something called as what we say? Electric susceptibility. Okay. So, tell me what is the difference between these two terms? Both are same, both are different. This gives what information and this gives what information? What is the information that you are going to get from, what is the name of this symbol? Epsilon. Epsilon. What it is? Chi. So, both are same, both are different. If both are different, in what way they are different? One example. This is a dielectric material. Let us check. Classroom is a dielectric material. I want to say something so that you must get that knowledge. Adi polarization anukundam. Okay. Between you and me, what is there? Atmosphere is there. If AC is not working, outside temperature is high. How about the class environment? Your behavior? AC is not there. Outside it is shiny. When it is shiny, how it will be inside? Somewhat ఏమంటారు దాన్ని స్లట్రియా ఉడకపోతుంటారు చూడండి ఏమంటారు స్వెటీ ఉంటుందా ఎట్ దట్ టైమ్ వాట్ ఈస్ యువర్ సిచ్యువేషన్ one case outside high shiny AC is there your situation now both are same when environment is not suitable if environment is not suitable how about student behavior if environment is suitable how about student behavior so environment information is epsilon chi related to the student only. Student means this classroom. Okay. About surroundings information epsilon, about material information chi. Saying something, some will get, those are listening, those are not listening, they won't get it. Some will feel difficult to listen because some fundamentals are there, if knowledge is there, some fundamental basics are there, you can follow. If there is no basic, when many doubts will come into the mind, you don't know what is what, then your such type of students response how it will be? నేను అడిగేది మీకు అర్థమైందా యూ గాట్ ఫండమెంటల్ ఓకే ఫర్ ఎగ్జాంపుల్ టేక్ లాంగ్వేజ్ మీకు తెలిసిన లాంగ్వేజ్ ఒకటి తెలుగు ఇంకొకటి తర్వాత హిందీ వస్తుందా వస్తే ఓకే రైట్ కన్నడం మాట్లాడుతున్నారు మలయాళీ ఓకే two students are discussing Malayali, you are there, how much you are going to get? సరే ఇప్పుడు లాంగ్వేజ్ నేర్చుకోవాల్సిన పని లేదు కానీ సేమ్ ఎఫెక్టా లాంగ్వేజ్ తెలిసి ఎట్లా ఉంటుంది తెలియకుండా ఎట్లా ఉంటుంది ఏమేన్ ఎగ్జైటెడా లాంగ్వేజ్ తెలిస్తే ఏం మాట్లాడుకుంటూ అర్థమవుతుంది లాంగ్వేజ్ తెలియకపోతే అంతేనా అంటే ఒక సబ్జెక్ట్ బేసిక్స్ తెలిస్తే సబ్జెక్ట్లో ఏముందో నేర్చుకోవాలని ఆలోచన ఉంటుంది బేసిక్స్ తెలియకపోతే దాని మీద ఇంట్రెస్ట్ వస్తుందా నేర్చుకుంటారా ఎస్ ఆర్ నో అంతే ఇది కూడా దీస్ ఆర్ ద ఫండమెంటల్స్ రిగార్డింగ్ డైఎలక్ట్రిక్ మెటీరియల్స్ ఇవన్నీ దేనికి డైఎలక్ట్రిక్ మెటీరియల్స్ రిలేటెడ్ ఫండమెంటల్ టాపిక్స్ మెయిన్లీ ఎప్సిలాన్ chi epsilon related to medium, chi related to the substance, how easily it can polarize it. Polarize ante enti malli formation of poles. When the poles are going to form, where the poles are going to form inside the material. When external field is going to apply. Means before applying field how the situation, how the arrangement will be, the centers of positive and negative charge will be same or different. See one by one we are coming or not. Dipole, తర్వాత dipole moment, after that dipole, first what we came to know, actually what are the use of dielectric materials. What happens sirs? All are busy, bending their heads and sitting in the classroom. What it indicates? Bending head and sitting means what? Writing Sir, back, you only. Yes, stand. నువ్వే రెడ్ షర్టా పక్కన వాట్ ఆర్ యూ డూయింగ్ ఏం చేస్తున్నావు మరి తల కిందికి ఎందుకుంది అబ్బా సార్ డిడ్ ఐ ఆస్క్ యూ టు టర్న్ యూ డోంట్ టర్న్ యువర్ బాడీ please be seated. Right. So, first what we discussed in this, what are dielectrics? Before that What is the use of dielectrics? Yes or no? Then what are dielectric materials? Means for understanding purpose, we compared dielectric material with what? Insulators. We compared dielectric materials with insulators. Then after that, actually what is going to happen inside at atomic level when external field is going to apply? Means dipoles, dipole moment. Then after that, dipole moment tarvata next polarization. Next, after polarization, polarizability. After polarization, polarizability. After polarizability, permittivity. We discussed about permittivity. Tarvata permittivity tarvata susceptibility. Permittivity, susceptibility, permittivity of free space and relative permittivity, and the relation between these two. Antena epsilon r is equal to epsilon by epsilon naught. Ratio between permittivity of a medium to permittivity of free space is called as relative permittivity. Okay, right. Next, displacement vector. Next, we are going to say displacement vector. Displacement vector or dielectric displacement law. It is also called as dielectric displacement law, which is given by d is equal to epsilon naught E plus P. D is equal to what? Epsilon naught E plus P. Okay, so we are going to see the derivative part for this. For that purpose, we use Gaussian law. What is that Gaussian law? Integral E dot ds is equal to 1 by epsilon naught into q. This formula we are going to use it. Okay. I think you studied this in where? Second year, inter second year. Okay. So, if we take two plates, okay, two plates, when you connect to electric field depends upon the polarity. One plate develops positive charge, other plate is going to develop negative charge. Okay. So, between this positive charge and negative charge, one electric field is going to induce or develop. What is going to develop? Electric field is going to develop. That electric field we call as E naught. Between the positive and negative charges, and electric field is going to set up. That electric field from positive to negative, which is given by E naught. Okay. Now, by using this Gaussian law, integral E dot ds is equal to 1 by epsilon naught into q. From this, E into integral ds is equal to 1 by epsilon naught into q. So, this one I will take area of cross section E. E dot A is equal to 1 by epsilon naught into q. Then E is equal to what? Q by epsilon naught A. Expression for electric field E, which is given by E is equal to q by A epsilon naught, where q is the charge, A is the area of cross section, epsilon naught is the permittivity of free space or air. So, here we take a plate just like capacitor, two plates connected to field. Positive charge is going to develop on one plate, negative charge is going to develop another plate. This is what a Gaussian equation. From Gaussian equation, electric field E, which is equal to what I write? Q by epsilon naught A. Okay. Right. Now, what I do? Between the plates, one dielectric material is inserted. This is positive plate, this is negative plate. Now, between the plates, what we kept now? One dielectric material is inserted. Now, on the material, because of this field, charges, polarities created, those charges, induced charges I can say. So, positive will induce negative charge and negative side positive charge. So, again we are going to see an electric field, that is E p. Previously E naught, now E p field is developed because of the charges which are produced on the slab. The slab is what? Dielectric material. Okay. If I take this charge is q plus q, and whatever the charge plus q minus q will be same, the charge that is developed is q dash or q prime. The induced charge on the dielectric material is q dash. Okay. And if you see q and q dash, it will not be same. The charge that is developed on the plate and the charge that is induced on the dielectric material is not going to be same. Q and q dash will be different. Okay, na? Right. Now, first electric field is E naught, second electric field is E p. See the direction, same direction, opposite direction. So, automatically that is why this will act as an insulator. They are opposing, does not allows. Okay, the charge that is induced is opposite to the field. So, when it is opposite, it allows, it is not going to allow. So, what is the effective electric field now? Effective electric field E. You can write or not? E naught minus A p. Okay. Now, what about the effective charge? Q minus Q prime. Okay. This is effective charge and effective electric field. Again from Gauss's law. What is Gaussian law? Integral E dot ds is equal to 1 by epsilon naught A actually, sorry. 1 by epsilon naught q, general expression. But here q is equal to what I have to write? Q is equal to what? Net charge, q minus q prime. So, in the place of q, what I am writing? I can write on, right, same thing, continue. So, E dot A is equal to q minus q prime by epsilon naught, where integral closed surface area is how much? A. So, from this A is equal to what I can write now? Q minus q naught by epsilon A. I can write or not? Rearrange the terms. You rearrange it in such a way that by epsilon naught A is equal to q by epsilon naught A minus q prime by epsilon A. We can write or not? Okay. From this time you bring this side. What will come? E plus q prime by epsilon naught A is equal to what? Q by epsilon naught A, or q by epsilon naught A is equal to what I can write now? E plus q by something is wrong. Where I made mistake? Q prime వస్తుంది కదా. Okay na? Up to here it is clear? Where E minus? This term if you bring this at E, minus value become plus this value as it is I wrote. Then I made LHS to RHS, RHS to LHS. Now we are going to write here, okay, this is equation. Any number I took? Previously I like this one equation 1 ante 2. Right, here I am going to write polarization vector P in terms of prime. Polarization vector P is q prime by A I am writing. Actually, what is polarization vector? What is polarization vector? Definition of polarization vector: dipole moment for unit volume. Yes or no? Dipole moment for unit volume. But there I took only area. If I multiply the numerator and denominator, what will come? The name right? Q prime into time by A into T. ఏమవుతుంది? Since volume is what? I can write or not? P, polarization vector P is q prime by A, or if I multiply time numerator and denominator, okay, area into time we get a volume. So, we get P is equal to what? Q prime times T by V. Now, so what is equation to now? Q by epsilon naught A is equal to E plus Q dash by A is equal to what? I can write or not? Because P is equal to what we shown? P is equal to Q dash by A, right. Rearrange it. Multiply epsilon. Q by A is how much? Epsilon naught E plus P epsilon naught by epsilon naught. Okay, this epsilon I am taking this side. So, Q by A is what? Epsilon naught E plus P. Q by A is equal to what? Epsilon naught E plus P. This I will take as D. That I will take as D, called as displacement vector. So, D is equal to Q by A or epsilon naught E plus P. Therefore, D is equal to what I can write now? Displacement vector D is equal to epsilon naught E plus P. Next, what happened? Time is up. Then why sound is coming? Relation between epsilon r and chi. Actually, these formulas are used for solving problems. Displacement vector formula and this one used for solving problems. Epsilon r is equal to 1 plus chi. What is epsilon r? Relative permittivity. What is chi? Electric susceptibility. So, sometimes he may give you electric susceptibility and he may ask you to find relative permittivity, or relative permittivity will be given, he may ask you to find electric susceptibility. Okay, na? Right. To derive this relation, we make use of polarization vector P. We know polarization vector. So, polarization vector P, what is the polarization vector P? In terms of electric susceptibility, P is equal to epsilon naught chi e. Expression for polarization vector is P is equal to epsilon naught chi e. So, we know displacement vector, just now we say D is equal to what we know? D is equal to epsilon naught E plus P. Substitute P here. So, from this D is equal to what? Epsilon naught E plus can be so D is equal to epsilon naught E plus. Okay. So, what will come out if I simplify this? Epsilon naught E, if I take outside 1 plus chi. From this D by E is equal to what I can write now? Epsilon naught into 1 plus chi. This is nothing but epsilon, which is equal to epsilon naught into 1 plus chi. But what is epsilon r? Epsilon by. So, from this epsilon, so what will come? epsilon r epsilon naught is equal to epsilon into, so cancel epsilon naught, this is another formula is there for this, d is equal to epsilon e, from this epsilon is equal to d by e. So, these two relations are used for solving problems only. Before this relation, displacement vector d, which is equal to epsilon naught e plus p, and here relation between epsilon r and chi. Epsilon r is nothing but what? Relative permittivity, and chi is electric susceptibility. Excited? Exhausted? Why? Sitting and listening only, na? Okay, you stand, feel, you say something and feel exhausted. Stand and speak. Or relations, two relations, not to 3 or 4 relations we seen. What are the mathematical equations that we seen? Tell me. What and what we seen? Tell me. Kaipole? Huh? Tell me the equations that we studied unit till now. Amma? Mu is equal to q into d. Good. Next. Epsilon is equal to d by e. Next. Epsilon r is equal to epsilon by epsilon naught. Next. N ఇంకా mu by e ఇంకా chi is equal to Next. Next. These are the formulas that we came across till now in this chapter. Am I right? Keep these formulas in mind for solving problems. Okay, na? Because this might be helpful for solving problems. Next. Yes. Formulas only. That also you want to write? Afterwards you write. Think and write. Okay, all of you, take pen and paper, turn back side, turn the book back side, write the formulas that you learned till now. Write the formulas without seeing, just write the formulas only. I will see how many. Already I wrote now. I will see how many of you are going to write. Write the formula, only formula, don't see. Close, think and write. How many you can write, you check yourself. Don't see, don't copy. Just think and write. You check up to what extent you can write. Backside you write somewhere else. Just formulas రాయండి, మిగతా ఏం రాయకండి. I will see. Back side రాయమ్మా, సపరేటా? ఓకే, రైట్. Don't see, boy. Don't see. Think and write. If you are writing by seeing, waste don't write. Sit idle. Great, you don't have paper also. How many formulas are there nearly? Around 10 formulas. Yes or no? Can you write all those 10 formulas there? Right, just test your knowledge. Up to what extent you can write. Why are you drawing Brack's law? Did I teach Brack's law now? Then why are you drawing that? Trying, huh? Which topic we discussed? Please stand. Tell me your name.
Sir, K. Rajesh.
Rajesh, which topic we are discussing?
Polarization.
Topic name, title of the unit. First unit title in your textbook? First unit and title unda? Ikkada levu.
Sir, I know units, sir, but topic
Did I wrote on the board or not? What I wrote? First, before formula, topics. Before topics. ఏం రాశాను? Learning is different. అంటే without knowing unit, many students does not know the name of the unit also. Not only one more is there, your friend is there. Your friend is also there. అంటే ఇక్కడ ఉన్నారా లేరా మీరు? Physically you are here, am I right? అంతే. Stand and speak. Stand. Tell. dielectric materials. Clear? Magnetic materials. Who is it? Okay, over writing. Writing completed. Andarika. Stand and speak. Okay, you wrote formulae. Hardly how many formulas you wrote, you know. You compare how many formulas I wrote on the board. Only formulas. I am not asking beyond that. So from that you check yourself where you are in the classroom. Which property? Related to dielectrics. If I apply that, which property I have to use? Electric susceptibility regarding what? Regarding the material or surroundings? What? What is that information you get? How easily we can polarize? How easily we can polarize? That information we get from electric susceptibility. Next, polarization types. From polarization, we get expression for polarizability. Yes or no? In polarization concept, we came to know about polarizability. Polarizability is indicated with letter alpha. What symbol we used? Right. There are three types of polarizations or polarizabilities. How many types? Three types. Electronic, polarizability, ionic polarizability, orientation polarizability. Electronic, ionic, orientation. These are the types of polarizabilities. Okay. Electronic polarizability indicated with letter alpha E, ionic polarizability alpha O, orientation polarizability, sorry, electronic alpha E, ionic alpha I, orientation polarizability alpha O. Let us see this middle one first, so that alpha I. Alpha I related to means what we can say? Any idea you are getting by seeing the title? Ionic. Ionic means chemistry word. Ionic means ionic bond. Yes or no? Where we see this ionic, where we find the ionic bond? Where we find ionic bond? In ionic substance. Where we find ionic bond? In ionic substance. What is ionic bond? What is ionic substance is made up of? Ionic bond. What is ionic bond? How ionic bond is formed? Where ionic bond is formed? Between cations and anions. Ionic bond is present between cations and anions. What is cation? Positively charged atom is cation. Anion. Cation. Anions. How these cations and anions are formed? Okay, positively charged, negative charge. How they are formed? By, you must know about ionic bond. How an ionic bond is formed? Already you said ions, positive charge, negative charge. How these positive and negative charges are going to develop on atoms? On atoms only? Positive and negative charge where we are going to find? ఎక్కడ ఉంటాయి? Where? Tell me where we are going to find these cations and anions, ionic substance annam. How these cations and anions are formed? Or how this positive and negative charge is developed? That is my question. By అర్థం కాలే. Slowly. Please repeat again. By nuclear reaction. నాకు కన్ఫ్యూజన్ ఉంది. ఎస్, ఇంకా ఏదో చెప్తాను, గట్టి చెప్పు. లౌడర్ యు స్పీక్. వెన్ న్యూట్రల్ ఆటమ్ gains. Yes, good answer. How these cations or anions are formed? In simple words, transfer of electron between atoms. Transfer of electron between atoms. Why the electron transfer takes place between atoms? Fundamentals, all these are related to this. Idea must be there. Why the electron transfer takes place between atoms? Louder you speak, amma. Good. To get a stability. To get a stability. Atoms loses electron or gains electron. When an atom loses electron, it develops positive charge. And other atom which is gaining electron develops negative charge. So positive charged atoms are called cations, negative charged atoms are called. So ion formation takes place by transfer of electron. Yes or no? Why the electron transfer takes place? To get stability. How you say that atom is stable, or when you say that atom is stable, or whether the atoms are stable or not in nature. If they are stable, which are stable? If they are not stable, which are not unstable? Basics, some idea must be there. That's why I am saying all these things. In nature, how many types of atoms are there? Periodic classification elements. How many elements are there? Around 110 plus elements are there. All are stable or all unstable? Some are stable, some are metallic, some are non-metallic, some are metallites. Yes or no? So which are stable? They are placed separately in the periodic table, called inert gases, zero group elements. They are in gaseous state, called inert gases. Why they named as inert? Because they don't participate in bonding. What are they? Helium, neon, argon, krypton, xenon. Radon is a radioactive element. Okay. Other than those elements, they are stable, they are unstable. So what they want? Stability. How they get stability? By getting octet configuration in the valence shell. By getting octet or doublet in the case of helium, remaining octet. So how the atoms get octet? Octet means 8 electrons. Okay. So how they get 8 electrons? Either by transfer of electron or by sharing of electron. If atom getting electron by transfer, where this transfer of electron is taking place, such bond is called as ionic bond, and the substance is called as ionic substance. So, in ionic substance, ionic polarizability we are going to see. Okay. And expression for ionic polarizability is E square by omega naught square into 1 by small m plus 1 by capital M. Expression for ionic polarizability is given as E square by omega naught square into 1 by small m plus 1 by capital M. Okay. So, we can see this ionic polarizability in ionic substance. If the substance is covalent substance, what is the meaning of covalent? What is the meaning of covalent substance? Ionic substance, ionic bond. Covalent substance, how a covalent bond is going to form? By sharing of electrons. Can we find this ionic polarizability in covalent substance? No. Okay. So, we are going to see in ionic substance, and it is independent of temperature. It is independent of temperature, and expression for ionic polarizability is given by alpha A, which is equal to E square by omega naught square into 1 by small m plus 1 by capital M. This does not occur in covalent substance or the crystals where covalent bond is going to present. Okay. Sir, ఇది థియరీ క్వాలిటేటివ్ ఉంది కదా సార్ సిలబస్, అయానిక్ సిలబస్లో క్వాలిటేటివ్ కదా సార్, నాకు ఇచ్చింది క్వాలిటేటివ్ ఉంది. ఎస్, ఐఎమ్ టేకింగ్ సమ్ క్లారిఫికేషన్. సో qualitative means try to remember this, derivation part is not necessary, but okay. So this information if given, it's enough. Next, coming to the first one. Okay, where we see this? What is the statement I can say it? Does not occur in. Just idea I will give. Okay, na? To derive this, already now we discussed that ionic bond. Ionic bond is a bond between cations. Okay. So initially in the absence of external electric field, I want to revise. So one is anion, one is cation. Whose mass will be large, whose mass will be small? Masses of anions and cations will be same. One example, let's take sodium chloride. It is an example of what? Ionic bond. Yes or no? In this, what will be there? Sodium ions will be there, chloride ions will be there. Masses of sodium will be same. So one mass is small m, other mass is capital M. Okay. Now what we do? We apply external electric field for this. So what you are going to see? When you apply external electric field, what is going to happen? ఏమవుతుంది? Polarization is going to take place. What is going to take place? Polarization. Polarization means these are going to be separated. Antena? So from mean point x1 distance, x2 distance, two poles are created. Dipole moment untunda. What is dipole moment? Mu is equal to what here? The distance between the ions. What is it? x1 plus into d. ఇది ఒక ఫార్ములా యూజ్ చేస్తాం. mu is equal to x1 plus x2 into d. One formula. Next, here this one concept we are going to say that K1 and K2 are the restoring forces constants of both the ions. K1 is the restoring force constant of this ion. K2 is the restoring force. So then F is equal to what I can write now for this? x1 K1 and F is equal to x2 K2. Therefore F is equal to restoring force constant. F stands for restoring force constant. So from this x1 is equal to what we write? F1 F by K1, and for this x2 is equal to what I write? Okay na? So force here going to explain what we are passing. So expression for force in terms of electric field, F is equal to EE take. F is equal to EE. Where E is the charge, capital is the electric field. And restoring force constant K is equal to what we know? M omega naught square. K is equal to M omega naught square. For first one, small one, capital M. Okay. So K1 will come, K2 will come. If you substitute x1, x2 will come. That x1, x2 if you substitute here, then mu will come. Then if you simplify, you will get a alpha which is equal to E square by omega naught square into 1 by small m plus 1 by capital M. If will come. ఇక్కడ వచ్చింది కదా, ఎఫ్ ప్లేస్లో ఈ సబ్స్టిట్యూట్ చేయండి. K1 అన్నప్పుడు స్మాల్ ఎమ్ ఒమేగా నాట్ స్క్వేర్, ఇక్కడ ఈ బై క్యాపిటల్ ఎమ్ ఒమేగా నాట్ స్క్వేర్. ఈ రెండు వాల్యూస్ ఎక్కడ సబ్స్టిట్యూట్ చేయండి? ఇక్కడ సబ్స్టిట్యూట్ చేయండి. మ్యూ బై డి ఏమవుతుంది? ఆల్ఫా అయిపోతుంది. ఇన్ దట్ వే యూ విల్ గెట్ అ expression for alpha I, which is nothing but called as ionic polarizability. Okay, ఇంకా దీని గురించి what I can say further? What is omega naught? Generally what is omega? Omega stands for, it is a angular frequency, it is a constant. So what I can write further? Alpha I is directly proportional to E square. Alpha I is directly proportional to 1 by small m plus 1 by alpha I is directly, okay, sorry. E, sorry, what is constant? E, what is E? 1 minute. What is E? What is E? E stands for, electron charge value is going to be same, it will be varying from place to place or substance constant. So what I can write now? Inversely proportional to omega naught square and directly proportional to 1 by small m plus 1 by capital M. This is what? Which polarizability? Ionic polarizability. Which polarizability it is? Ionic. Similarly, second polarizability is what? That we are going to say is electronic polarizability. alpha E indicated with letter which is equal to 4 pi epsilon naught r cube. Alpha E is how much? 4 pi naught r cube. ఏం రాస్తున్నామా? ఆ ఫార్ములా you try. You write by seeing the formula. Right. Alpha E, same concept. Mu is equal to x1 plus x2 into d, x1 x2 to find. Generally this this is produced in all the substance when electric field is going to be applied in all materials and proportional to the volume of the atoms in the material. When we apply electric field, this we are going to see, and it is proportional to the number of atoms in the material, given by the formula alpha I, which is equal to 4 pi epsilon naught r cube. 4 constant epsilon naught medium. So what I can write, it is directly proportional to r cube, and it is also independent of temperature. It is also independent of temperature, because any temperature is there, temperature is not there. So if you vary the temperature also, no effect. Next, the third one is orientation polarization. Alpha O. Orientation. What is the meaning of orientation? General meaning of orientation. Orientation అంటే ఏంటమ్మా? Orientation అంటే ఏంటి? What is the meaning of orientation? Yes? Why are you standing? Okay, right. Good. So you are giving company to me in the classroom. So what is the meaning of orientation? ఓరియంటేషన్ అంటే ఏంటి తెలుసా? ఓరియంటేషన్ అంటే ఎస్, random, how the dipoles arrangement. Here if I take classroom, how the students are oriented, I am using the word with respect to students. How the students are oriented in the classroom? All are facing towards board or different directions you are facing and sitting. ఎట్లా కూర్చున్నారమ్మ అందరూ? ఒక ఓరియంటేషన్ ఉందా లేదా అందరికీ? ఎస్ ఆర్ నో? ఆల్ ఆర్ ఫేసింగ్ టువర్డ్స్ ఇన్ ద సేమ్ వే dipoles orientation. From that we are going to get orientation posability alpha, which is equal to mu square by, expression is what? Mu square by 3 kb into t. Mu square by the forcibility is given by mu square by 3 kb into t. What is mu? అంటే where we see this, where dipoles are present. Where dipoles are present, there this orientation polarization we are going to see. Equation is mu square by 3 kb into t. What is mu? Dipole moment. Kb Boltzmann constant. T temperature. So previous two cases, any temperature what is there? No. Here temperature is there, and how it is? Directly related, inversely related. Means as the temperature changes, orientation is going to change, dipole moment is going to change like that. Okay. So where these polar molecules are present, there we are going to see this dipole moment. Okay. Next, Polar molecules have permanent dipole moment even in the absence of electric field. Generally, another property of polar molecules, in polar molecules we are going to see. Polar molecules are the molecules which have dipole moment even in the absence of external field. Dipoles are present. In the means random orientation of dipoles you can see in polar molecules. When such substance is kept in external electric field, the random orientation changes into regular orientation. Regular orientation means, for example, I will take one substance contains two types of orientation. Dipoles orientation is random. Now in the presence of field, what I am going to see? So external field is 0, some external field is applied. So this is a change that we are going to see. Orientation polarization or orientation polarizability, we can say it. Means even in the absence of field, already dipoles are present or not. Next, okay. So three types of polarizabilities you seen. What and what? Alpha I, alpha E, alpha O. I, ionic polarization, ionic posability. E, electronic posability. O, orientation posability. When I sum them, then I will get resultant one. The resultant polarization is called as space charge polarization or space charge posability. The sum of ionic posability plus electronic posability, orientation posability gives you space charge polarizability, or ionic polarization plus electronic polarization plus orientation polarization gives you charge polarization, and the corresponding polarizability we call as space charge posability. That is alpha is equal to ionic. Ionic is what? E square by omega naught square into 1 by small m plus 1 by capital M plus electronic 4 pi epsilon naught r cube plus mu naught alpha O mu square by 3 kb into T. The sum of those three gives you space charge posabilities. Okay. Then after this we are going to say one more important topic, Clausius-Mossetti relation. Clausius-Mossetti relation is the next topic that we are going to see. The topic is depending upon this polarizabilities only. Amen. Clausius-Mossetti relation. ఏమైందమ్మా మా కూడా చెప్తే మేము కూడా అవుతాం కదా. జోక్ మీకేనా మాకొద్దా? అందరికి షేర్ చేసి అందరు ఎంజాయ్ చేస్తారు కదా, వద్దా? The mathematical equation for this relation is epsilon r minus 1 by epsilon r plus 2 is equal to n alpha e by 3 epsilon naught. దీని ఏమనాలి? Clausius-Mossetti relation. Clausius-Mossetti relation. What is the Clausius-Mossetti relation? Epsilon r minus 1 by epsilon r plus 2 is equal to n alpha e by 3 epsilon naught is Clausius Mosetti relation. I think the terminology that I wrote in this relation, all terms we discussed in this class, am I right or not? Check and say. The terms that I used in the equation, did we discuss or not? అన్ని టర్మ్స్ చూసినట్టున్నావు, కొత్తగా ఉన్నాయేమన్నా? చూసినట్టే ఉన్నాయా? సో వాట్ ఈస్ వాట్? ఎప్సిలాన్ ఆర్. వాట్ ఈస్ ఎప్సిలాన్ ఆర్? రిలేటివ్ పర్మిటివిటీ. ఎన్ నెంబర్. ఆల్ఫా ఈ ఎలక్ట్రానిక్ పోర్టబిలిటీ. ఎప్సిలాన్ నాట్ permittivity of free space. So this may be asked in this way: derive Clausius Mosetti relation, direct question, or derive the following relation అని చెప్పి the equation may be given, or write the relation between dielectric constant, electronic possibility and ఇంకోటి ఏంటి? permittivity of space. Derive the relation between dielectric constant, electronic polarizability and permittivity of free space. Please stand. Good name? Please, he is introducing himself in the classroom. What's a good name? Good? Huh? కొద్దిగా మెల్లగా. నీ పేరయ్యా? నిహాంత్. నిహాంతా? ఓకే, డన్. రైట్. ప్లీజ్ కెన్ యూ స్పీక్ అబౌట్ దిస్ ఈక్వేషన్? You speak this, you spell this, read this. Please, malli repeat. ఇది ఎప్సిలాన్, ఇది ఎప్సిలాన్ ఏనా? ఓకే, డన్. ఇన్ అదర్ వే, you know what is the meaning of epsilon r, what is the meaning of epsilon naught, what is the meaning of alpha e? Use them and speak. What is this? Epsilon r? Relative permittivity. Good. Alpha e? Electronic polarizability. Good. What is epsilon o? Let him speak. ఆలోచించలేనా? Permittivity of free space. Okay, this relation we have to derive. We have to derive this relation. Hema? Yes. ఏమైందమ్మా? You want break? 37:40 అవుతుందని చెప్పి ఆలోచిస్తున్నాను అంతే. వెళ్ళాలంటే వెళ్ళండి. They need 2 minutes. Please. Okay. To derive this relation, we take a dielectric substance, cubic substance. Let us take a dielectric substance. You know, cubic substance means shape is in the form of a cube which does not have any ions, which does not have any ions and no permanent dipoles. We take a substance, cubic substance which does not have ions and also which does not have any dipoles. No ions and no dipoles means, what about ionic possibility and what about orientation possibility? No ions means ionic possibility will be, orientation possibility will be, first only we take a substance free from ionic as well as dipoles, means no ionic possibility, no orientation possibility. Then which possibility will be there? Only electronic possibility will be there. Which will be there? Only electronic possibility. Actually, before this topic, one more topic we have to discuss, because that application we are using here, that I will tell answer, because it is a somewhat time taking process. This is substance. Okay. External field is applied. External field is applied. How much we have to see inside the substance? When external field is going to apply, the field that is developed inside the substance must be how much? ఎంత ఉండాలి in general? The field that is present inside will be equal to E plus P by epsilon naught. The field, internal field in solids, we used to say it. What we used to say? Internal field in solids, which is given by EI, which is equal to E plus P by epsilon naught. Means what did you understood from that equation? E is applied field. Means when you apply electric field on a substance, along with applied field, we see additional factor. How much it is? P by epsilon naught. What is? Time to recharge mobile in the classroom. Is it necessary to recharge? Important, huh? Might be. Couch. So what we are going to see? ఏమ్మా గోర్లు ఉంటాయా? అప్పటి నుంచి చూస్తున్నా, కష్టం కొద్ది తినేస్తున్నాం. So what we are going to see? Some additional value we are going to see. How much it is? P by epsilon naught. What is P? Polarization. What is epsilon naught? Permittivity of free space. So that derivation is there actually for that. Okay, Lorentz method. Lorentz has given that. 1 minute. Internal field in solid by Lorentz method. Internal field in solid by Lorentz method. According to the title, E will be equal to E, the field that is developed EI is equal to E plus P by epsilon naught. That application we are using in this derivation. Okay, now clear? Right. So here we take substance free from ions as well as dipoles, no ionic possibility, no orientation possibility, only one possibility, that too electronic possibility. So from the definition of polarization, P, N alpha E into E, I can write or not? One possibility is there, that too electronic possibility. Polarization takes place in the presence of electric field E in number of atoms. Okay, but already we know, according to that method, E is equal to what we write? EI. Yes or no? We are applying field. When the polarization takes place? When we apply field. Okay, so P is equal to N alpha E into EI. But what is EI? Just now I should. Derivation part that we shall see afterwards. Okay, P by epsilon naught. So P is equal to what? N alpha E into P by, okay, sorry, small 3 epsilon naught. E is equal to A plus P by 3 epsilon naught, not E, 3 times of epsilon naught. So ఇంకేమవుతుంది? P is equal to ఏమవుతుంది? N alpha E plus N alpha E P by 3 epsilon naught. Here P is there, here P is there, bring P terms one side. P minus N alpha E P by 3 epsilon naught is equal to n alpha e into E. Now, what I can take outside? P 1 minus n alpha e by 3 epsilon naught is equal to n alpha e into E. So, from this we are going to write expression for P. So, P is equal to what I can write now? N alpha e by 1 minus n alpha e by 3 epsilon naught. Let us take this as equation 1. Up to here it is clear. First we took expression for polarization. E replaced with Ei, which is equal to E plus P by 3 epsilon naught. Then rearranging, we got expression for P, which is equal to n alpha E by 1 minus n alpha E by 3 epsilon naught. Right. We also studied from the definition of displacement vector from d is equal to what? Plus P. D is equal to epsilon naught E plus P. So, from this P is equal to what? D P is equal to D minus epsilon E. Okay. Okay. Bring this E this side. P by E is equal to di minus epsilon naught. So, P by E is equal to d by E is what? Already we seen. D by E is what? Epsilon. So, from this P is equal to what? Epsilon minus epsilon naught into, I can write epsilon minus epsilon naught into E. Further P is equal to what I can write now? What is epsilon? We know epsilon r is what? Epsilon by epsilon naught. From this epsilon is epsilon r epsilon naught. So, P is equal to what? Epsilon r epsilon naught minus epsilon naught into E. So, P is equal to epsilon naught epsilon r minus V into E. P is equal to epsilon naught E epsilon r minus 1. Equation 2. What is equation 1? P is equal to n alpha E by 1 minus n alpha E by 3 epsilon naught. What is equation 2? From equation 1 and 2, n alpha E by 1 minus n alpha E by 3 epsilon naught is equal to epsilon naught epsilon r minus 1 into E. Just so cancel E on both. Sorry for the disturbance. I am feeling free now. Okay. Hello. So, n alpha E by 3 epsilon naught is equal to epsilon into epsilon r minus 1. Any doubt up to here? A complete mathematics simplification process. Right. So that I am writing here. Any problem? This one I am. This one I am writing here. Okay. N alpha E by this one you take there and that one you bring this side. Epsilon r into epsilon r minus 1 is equal to 1 minus n alpha E by 3 epsilon naught. So this one you bring this side, n alpha E by epsilon naught into epsilon r minus 1 plus n alpha E by 3 epsilon naught is equal to, so what is common here? N alpha E by epsilon naught, if I take outside, 1 by epsilon r minus 1 plus 1 by 3 is equal to 1. Shall I write beside? Simplify this. N alpha E by ఇది లేదు epsilon naught ఏమొస్తుంది 3 plus epsilon r minus 1 by 3 into epsilon r minus 1. So what will come? N alpha E by epsilon naught into epsilon r plus 2 by epsilon r minus 1 into 3 is equal to 3 out I brought outside. So from this n alpha E by 3 epsilon naught is equal to epsilon r minus 1 by epsilon r 2 r then ingo epsilon r minus 1 by epsilon r plus 2 is equal to n alpha E by 3 epsilon naught. This is Clausius-Ponseti relation. What is here? Always bending your head, Amma? Pen? Pen there, book there, bending. Writing? Writing, huh? Derivation wrote? You want phone, huh? Then keep that phone aside. Reverse it. Reverse the phone and keep. Notification వచ్చిన disturbance ఉండదు. Done. This derivation is somewhat interesting. Try. Same pattern you do. అరే డోంట్ కాపీ ఈచ్ అండ్ ఎవ్రీ వర్డ్ ఫ్రమ్ ద బోర్డ్. ఫస్ట్ స్టెప్ చూసుకొని కొన్ని స్టెప్స్ వేయండి సొంతగా. ఇది అయిపోతే జస్ట్ 2 minutes అది మెయిన్ కాన్సెప్ట్ చెప్పి ఇంటర్నల్ ఫీల్డ్ అండ్ సాలిడ్ ఉంది కదా. షల్ ఐ ఆఫ్టర్వర్డ్స్ యుల్ రైట్? గ్యాప్ వదిలిపెట్టండి, ఆ స్టెప్స్ మీరు సొంతంగా వేసుకోండి అమ్మా. ఈ డెరివేషన్ రాసారా? రైటింగ్ ఈజ్ ఓవర్. షో యువర్ కాపీ. అంత ఫాస్టా? ఏ గ్యాప్లో రాసావమ్మా? ఓ అంత ఫాస్ట్ ఉన్నావు, సూపర్ ఫాస్టా? ట్వెల్వ్కి 12:15 రైట్. ఆ టాపిక్ కవర్ చేయొచ్చు. రండి. అయిపోయిందా? కంప్లీటెడ్? అదే చెప్పాను, అదే అది వేరే కాన్సెప్ట్కి వెళ్ళి తీసుకున్నాను చెప్పాను. అది చెప్తాను. లో రేంజ్ మెథడ్ ఆఫ్ ఇంటర్నల్ ఫీల్డ్ ఫస్ట్ అందుకోసం చెప్పాను. ఇది యూజ్ చేస్తున్నామని చెప్పి డెరివేషన్ చెప్పాను. అది డెరివేషన్, అది కూడా చెప్తాను. అది ఏం సార్ ఫోన్లో ఏమన్నా అర్జెంట్ ఫోన్స్ వచ్చినాయా? మరి తీసినావు అప్పుడే చూస్తున్నావు, రిఫ్రెష్ చేస్తున్నావు. పక్కన పెట్టి మరి ఫోను లేదు ఉండలేరా? ఏం అలవాటయ్యా ఫోను? రివర్స్ పెట్టు. అర్జెంట్ ఉంటే సాయంత్రం చూసుకోవచ్చు. మీరంతా బిజినెస్ మేనా? ఏమన్నా పార్ట్ టైం జాబ్ ఉందా? సైడ్ ఇన్కమ్ ఉందా ఏమన్నా? ఇప్పుడు తర్వాత చూడాలి. ఇప్పుడు బ్రాక్స్లో ఎందుకు రాస్తున్నావు? లే ఓపెన్ చేయి. అప్పుడు నువ్వు ఓపెన్ చేయి. అప్పుడు చూస్తే డయాగ్రామ్ ఉంది, ఇప్పుడు చూస్తే మ్యాటర్ ఉంది. ఏమనుకోవాలి? నేను ఒక హాఫ్ అన్ అవర్ బ్యాక్ ముందు మాట్లాడిచ్చానా? అప్పుడు ఏమని చూపించినావు? ఆ బుక్ తీయో తీ. అదే నాకు గుర్తుంది, కలర్ గుర్తుంది, పేపర్ కలర్. ఈ డయాగ్రామ్ మాత్రం చూశాను. ఎస్ సార్ నో. ఇప్పుడు ఏం చూస్తున్నా? ఎక్కడికి వెళ్ళి వచ్చింది ఈ గ్యాప్లా? సరే, ఈ గ్యాప్లో అక్కడేం చేసా? ఏం ప్రాబ్లం? ఏం థియరీ చెప్పండి మిస్టర్ రాజేష్ గారు, చెప్పండి. నన్ను బ్లేమ్ ఫూల్ చేయకు. హాఫ్ అన్ అవర్ బ్యాక్ సార్, హాఫ్ అన్ అవర్ బ్యాక్ డయాగ్రాము, ఇప్పుడు విత్ మ్యాటర్. ఏమనుకోవాలా? కూర్చోయ్యా. నెక్స్ట్ క్లాస్ నేను వస్తానా? చూద్దాం అప్పటికి. నో నీడ్. రాయండి సార్ ఫస్ట్. అర్థం కాలే? ఎక్కడ అర్థం కాలే? ఈ టోటల్ టర్మ్ ఇక్కడ తీసుకొచ్చాను, ఈ టర్మ్ ఇక్కడ తీసుకొచ్చాను. చూడు అక్కడ టోటల్ టర్మ్ తీసుకెళ్ళు. ఫైనల్ ఒక స్టూడెంట్ డౌట్ అడిగాడు. గ్రేట్ సార్, ఎన్ని రోజులే సార్ బుక్ మీద రాయక? అంత కష్టంగా రాస్తున్నావు, ఫ్రీగా రాయట్లేదు. చెయ్యి. డోంట్ క్లోజ్, యూ రైట్, డూ యువర్ వర్క్. ఐ నో. అరే యు ఆర్ రైటింగ్ బాయ్, బట్ యు ఆర్ ఫీలింగ్ డిఫికల్టీ ఇన్ రైటింగ్. దట్ ఈజ్ మై క్వశ్చన్. నాకు చూడు, పెన్ను కష్టంగా పడుతున్నావు అంటే రాయడం చాలా తక్కువ ఉంది. ఎందుకు నొక్కి పెట్టి రాయాలి? సరే ఓకేనా సార్? బోర్డు మీద చేయగలుగుతావా? ట్రై చేస్తావా? ఎందుకు? నువ్వు సొంతగా చేసుకో. ఎందుకు కాపీ చేస్తావు? నువ్వు రాసావా? నీ బుక్ ఏది? తీ చూపించు. టర్న్ ద పేజ్. డెరివేషన్ ఏది? ఎప్పుడు? వాడెప్పుడు ఎక్స్ప్లెయిన్ చేయాలి నీకు? పని లేదా వాడికి? డోంట్ థింక్ ఇన్ దట్ ఐఎమ్ యూజింగ్ వర్డ్. వాడు ఓకే, ఫ్లో వచ్చింది. రైట్. వెన్ ఈజ్ గోయింగ్ టు టీచ్ యూ? హాస్టలా? నువ్వు ఇద్దరు ఇల్లు ఒకటే గారా? ఇద్దరు ఒకటే దగ్గర? ఒకే హౌజా? ఒకే గల్లీయా? గ్రేట్. Listen all of you, derivations if you write, then it will be there in the mind. If you don't write derivations while solving, many doubts will come. అది ఎట్లా వచ్చింది, ఎట్లా వచ్చిందని. రైట్. అమ్మా? ఎస్. Right. In this derivation, what did we used? We used one application, yes or no? Lorentz field of internal solid. Lorentz field of internal solid is a title. Title answer is EI, which is equal to E plus P by 3 epsilon naught. EI is equal to E plus P by 3 epsilon naught, low range field of internal solid. Okay, right. How this derivation is made? We take a parallel plates. Okay, so between these parallel plates, one dielectric slab is introduced. Right. Inside dielectric slab, we take an atom. Yes or no? Circle is an atom, square is a dielectric slab, two lines are the plates. Okay, right. So when this is connected to field, positive charge, negative charge, what field is going to set up here on the plate which is connected to positive terminal? Positive charge. Negative terminal, negative charge. Okay. So one field is going to set up from positive to negative. That field is E1, I will say. What I say? E1. Next, because of induction, positive charge, which charge is going to induce on the dielectric slab? Negative. Negative side means positive charge. Again, one field is going to set up from positive to negative. That is E2. That is E2. Right. But dielectric slab is made up of atoms. So one atom I took, which is spherical. The upper portion, which charge is going to induce? Positive charge. And the lower portion, which charge is going to induce? Negative charge. Again, one electric field is going to set up. That is E3. So total how many fields are there? 3. E1, E2, E3. So the field that is set up, EI, E is nothing but E1 plus E2 plus E3 plus E4 we take. How many fields we are going to take? E1, E2, E3, E4. Okay, right. E1 will be equal to E plus P by epsilon. The field that is developed on the plates, EI is equal to E plus P by epsilon naught. E2 will be equal to minus P by epsilon naught. E3 will be equal to P by 3 epsilon naught, and E4 is equal to 0. E1 is equal to P plus P by epsilon naught, E2 is equal to minus P, E3 is equal to P by 3 epsilon naught, and E4 is equal to 0. Actually, there is a derivation part for this. So mathematics, complete mathematics. Okay. So directly we can use it. You substitute all these values, what will come, tell me? EI is equal to what? E1. What is E1? E plus P by epsilon naught. What is E2? Minus P by epsilon naught. What is E3? P by 3 epsilon naught. E4 is 0 we take. Why 0? Because we consider that electric field E4 with respect to other atoms which are present in the dielectric material, but here we take condition that there are no other atoms. If there are no other atoms, there is no electric field. That's why we take E4 is equal to 0. So if I calculate this, EI is equal to what? E plus P by 3 epsilon naught. So this is the expression for internal field in solid given by Lorentz. Okay. Here E1 is the field intensity due to charge densities. ఎట్లా వస్తుందంటే ఈవెన్ ఎట్లా వస్తుందంటే E1 is equal to P by epsilon naught ఈ ఫార్ములా నుంచి P, sorry, d by epsilon naught, sorry, d is equal to epsilon naught, sorry, d by epsilon naught E plus P by epsilon naught ఇదేమవుతుంది E1 is equal to epsilon naught E by epsilon naught E P by epsilon naught. So E1 is equal to E plus, in the E2 field induced there is no displacement, only polarization will be there, minus P by epsilon naught. Epsilon naught E value is not going to present in the P2. For E3 mathematics is there complete. What we do, we take a atom radius, we take a dA, the charge is, length in mathematics is there, so derivation not necessary in this point. Okay, so direct answer we are going to take it, whose value, simplified value is P by 3 epsilon naught value will come. So this is low range method of internal field in solids.